Okay, so what we were discussing is principle of superposition. What it says that action of A1 and A2 can be considered separately in order to obtain the deflections and the reactive support reactive forces independently. And then finally, you can combine and write the principle of superposition equation together to get the combined effect and simultaneous effect of A1 and A2. Because this has simplified so much our analysis, because you cannot analyze complex structure with so many forces together. So what we do is first we apply one force, we analyze the structure, second force, third force using simple equations, because if you apply only moment here and you can analyze the structure easily. If you apply only the force here, you can, but together it becomes a complex. So idea behind principle of superposition, this is one form. It is used in many other forms. Why we are able to use this superposition, I am again repeating, because we are going to have the force and the deformation linear relation between them. Linear means, I hope all of you understand linear and non-linear. Force and the deflection. If force deflection is proportional to power, force, let's say delta is equal to PL cube by 3 EI. Now L cube has power, everybody knows. L cube has power, but this P is not having power. P is not having power, it is linear first power, and delta is also having first power. So if both the quantities are related with each other with first power, we call it linear. And because of linear relation between force and deformation, we are able to do the addition, just the addition of these quantities. For example, here you can see the D, deflection, total deflection caused by A1 and A2. But if we analyze it separately, because of moment A1, let's say deflection here, because of A1, D dash, and second time, if you apply A2 and the deflection because of that, A2 is D double dash, we can simply do the addition total deflection D is equal to, you can see in this equation, D is equal to D dash plus D double dash. This we are able to do because of the linear relation. This you have to keep in mind, because when you go for higher studies, learn some advanced courses where non-linear word is being used. What do you mean by non-linear? The force and deformation may not be related linearly, because in some situation, you apply the force, but deformations are very, very large. Let's say some other form, exponential form, or it happens because flexible structures are having that. In another situation, there can be, the larger forces and the deflections are very small. In case of, let's say, concentrated loads and impact loading. It might happen in case of earthquake analysis of structure also, like, there are inertial forces. There you can see the non-linear behavior of the structure, non-linear relation between the force and the deflection. So deflections, when you calculate, the forces are having some powers, or deflections are having some powers mathematically. Power means, what do you mean by power in mathematics? In that case, we cannot use superposition principle. So it is only for linear structures, that you have to keep in mind. That is one significance. Second, I told you whether it is deflections or the forces, everywhere or in any other situation, in some other situation where we want to write the moment equilibrium equation, where we want to write the compatibility equation, we have used superposition principle there also. Here, I am just revising this concept in generalized way so that you can understand and keep it in your mind that, okay, this is how it is. And we are going to actually use it for solving our problem also. So you can see, okay, the A1, because of moment A1, you can have generate the reaction. Please understand, analysis of second beam is not same as analysis of first beam. So whatever RA, RB and MB occurring here is because of both loads. But in second structure, whatever RA is occurring is because of only A1. Because of only A1. Please understand this. You don't have to mix up both the analysis. These two are separate. These 1 and 2 are separate. Second, when you are applying moment, your reactions, value of the reaction will be different. It is not same as this RA. So I am calling it RA dash. And when you apply RB, the value of the moment, the reaction in the second beam will be different. That is RB dash. And this moment MB, I will call it MB dash. This is because of A1. And similarly, because of A2, you can generate another value magnitude. If you calculate the realistic values, you will come to know that this is different value than, these two values. This is the total one, final one. So we have equated it in our final equation. So because of A2, we have RA double dash, RB double dash, and MB double dash. So what we do is RA is equal to R8 dash plus R8 double dash. This is a superposition equation which is being applied for calculating the reaction RA at the support. Of course, we need to have some prior information. Let's say this is again statically indeterminate structure. So whatever method I know, let's say slope deflection equation or moment distribution or the stiffness method which we are going to learn, I should be able to analyze this structure first in a simple method, because again, I would not say this is a simple structure. This is not simple structure. This is again statically indeterminate. But together, these two loadings, it is becoming more complex. So individual loading is still, I can analyze easily. And then we can, use a superposition equation. Similarly, superposition equation is being also written for reactions RB is equal to RB dash plus RB double dash. And the last one, that is a moment. You can see here the moment MB, is a summation of effect of A1 force, MB dash and MB double dash. So I hope all of you have understood what is the meaning of superposition. It can be applied to forces. It can be applied to deflections also. Like you have seen, this is the deflection equation. It can be also applied to rotations. I have not mentioned additional rotation here that I can do. I can call it, okay, theta A theta A, because this is roller support. It will rotate, and because of together effect, we have theta A, but alone this moment will cause theta A dash. And because of A2, you can have theta A double dash. And I can write my superposition equation for rotation at support A, which is theta A is equal to theta A dash plus theta A double dash. So I hope all of you have understood. Anybody has any questions, you can please ask me right